Next up, we got another one of our own talented associates, Wayne Murphy. He's an enterprise technical expert and pretty much helped build our forensic lab from the ground up, which is state of the art. It's something I geek out in there. It's a neat thing to see. I'm really glad that he's here, that he could talk to you about some of the advanced data recovery techniques and some of the forensic stuff that we do there. So let's give a warm welcome to Mr. Wayne Murphy.
Yes, sir.
Thanks a lot.
Can you show me how to use this? I'm not quite. Gotcha. Good afternoon, SparkCon. What a great crowd. I've been sitting in here all day, and you guys are awesome. Some really good speakers, too. The bar is high. I'll try not to let you guys down. As Tim said, my name's Wayne. I have the pleasure of standing up here in front of you and representing some of the work being done in this very building that I'm guessing at least some of you don't even know is going on. I work for the Forensic Services team. And together with the eDiscovery team, we make up Walmart's crime lab. We give a lot of tours up in our space, and that's kind of become my go-to opener. I find that when you tell folks Walmart has a crime lab, you immediately get met with some disbelief, and then it opens up a lot of good conversations. Eventually, you circle back around to, well, that's just something you write over a door, but I can assure you it's not. We're a bona fide crime lab. I'll get back to that in just a second. First, there's my title. I missed that. Just a quick breakdown of how I want to spend our time. Tim only gave me 25 minutes, and any of you know me know the roughest time I'm going to have up here is keeping this to 25 minutes. So I'm going to kind of keep it brief. I would be remiss if I didn't first talk about the business of what we do, the core reason our team exists, what a crime lab is, what we do, the customers we serve, and what its value is to the company. I've got to at least use a little of my time for the business speech. For those of you out there that are very familiar with the forensic world and crime labs and all that stuff, just bear with me. I'll keep it brief, I promise, and then we'll get to the cool stuff, kind of to a point. Everybody that comes up and looks at the lab, the one thing I get asked over and over, they're interested in what we do, but everybody wants to hear the, I don't know, I'm going to call them horror stories, if you will. They want to talk about the cool stuff that's come through the recovery lab that I'm going to talk about in a minute. You know, the more mangled a device is that we've been able to recover, the better the story, right? And so, maybe less educational than some of the awesome talks that have been up here, but hopefully interesting and fun to you guys. We're just going to kind of go through a few cases. That's my teaser for that. I don't want to leave it up too long, but we'll get to it in a minute. So I mentioned we're an accredited crime lab. There's a group. Let's see if my laser pointer works on this screen. There is an accrediting body called the American Society of Crime Lab Directors. Any of you guys that are involved in this business are familiar with those guys because that's the group that accredits every officially accredited crime lab in the United States. The government labs, the three-letter agencies, the state crime labs, local labs if they're accredited, and a handful of private labs in the world that are fortunate enough to hold this accreditation. Walmart is one of those labs. It went to a great deal of effort. We have a great deal of support from leadership, and it's paid huge dividends. It buys us credibility in the legal world, so on and so forth. So what's a crime lab? I think everybody in the room is at least somewhat familiar with the concept. It's everywhere, right? It's fictionalized on TV all the time, and it's on the news. It's on CSI and SVU, and it's on Dexter. It's on everything, right? And a crime lab is simply an organization that uses forensic science. They take scientific techniques and apply forensic science. What is forensics? Again, a fairly familiar word, but we define it in our lab really specifically for a variety of reasons as the application of scientific techniques during the investigation of crime or dispute to be used in debate or court of law. So you know what a crime lab is? You know how we define forensics. The only other thing I need to add to it to kind of paint the base picture is that these accrediting groups, the American Society of Crime Lab Directors and their subsidiaries and whatnot, break that down into disciplines. There's forensic science disciplines and subdisciplines. The ones you're probably most familiar with are the stuff that's on TV, both fiction and the news all the time. DNA forensics, fingerprint forensics, blood pattern analysis, that stuff's all over the television. There's the weirder stuff, there's forensic dentistry, there's forensic cosmetology, all this stuff's real. Walmart doesn't do any of that. We simply don't have a need for that, right? Fortunately, we don't have a large need to analyze blood patterns and determine what happened there. I hope it stays that way over time. What we do have a large use for, and the subdisciplines that we are accredited in, is digital and forensic video, right? So computers, tablets, hard drives, thumb drives, anything that's digital, and then video. These guys didn't give me presenter mode. I got to figure out which slide's next, but that's good. Why in the world do we do that, right? We have, this is a very large company, a couple million plus employees and hundreds of thousands of endpoints and all that good stuff. Walmart has a large need to do investigations, internal investigations. We have a large need to participate in the legal world. Jerry likes to say that we have an impressive litigative portfolio. It sounds better when you put it that way, right? But there's investigators working, everything from allegations of inappropriate relationships out to crimes that happened on our property to the company's need to defend itself and respond to the judge's requirements in a court of law. And every one of those attorneys and investigators, in order to do their job, needs digital evidence. There's a digital element to almost every single case they work, right? They may need a collection of emails. They may need me to look at a computer or my colleagues to look at a computer and say, hey, what websites were visited, what USB drives were put in this machine, et cetera, et cetera. I'm going to push too many buttons. And that all needs to be done in a way that if it goes to a court of law, it gets in and it stays in. We focus on best practice stuff like chain of custody and rigor and reproducibility and all the stuff on the screen. I got to hurry up or I'm going to run out of time for the cool stuff. I'm going to skip some of this. Ignore that slide for a second. I do want to mention this. With that, and now that everybody, we're kind of all on the same page, right? You guys know what our core business is, why Walmart's involved in this business. One thing that our leaders had a great vision of several years ago is that we ought to take this business of being in forensics and leverage the fact that we're a huge company to our benefit. And I say that because a lot of forensic labs, really good forensic labs out there, are excellent at things like chain of custody and rigor and all the stuff that I mentioned until something's broken. You guys ever watch TV? It's always the same thing, right? The Jodi Arias case, the Zimmerman case, local stuff. There's always this one device, this one laptop that accidentally flew out of the window of my car and off a bridge and under a steamroller, and now it's accidentally, coincidentally not available for inclusion in my case. And the investigator really wants to see that. And unlike CSI and these other shows you see on TV that would like you to believe that forensic work and hardware repair are the same skills, they're really not, right? We can't just call Abby up and take it down to the lab and have it magically fixed. And a lot of really good forensic labs can't get into that business. They have, a lot of bad choices when their stuff's broken. It's send it out and have risks and all this other stuff. And I want to keep it brief and get to the good stuff. But in our case, we were a consumer of data recovery, and the idea was let's stand this up for business continuity purposes. Let's get really good at this. And it's been a huge win. I can proudly stand up here and tell you that we're well into the 7 digits annually if we're really conservative about how we frame the numbers in money we save the company. And that doesn't touch forensics. The big hitters come in and we can hit the home runs on forensic cases, class action lawsuits, pharmacy servers, flooded out in stores, you name it. I'm going to go through this pretty quick because I want to get to the case studies, but I do want to give just a brief, we're a crime lab, you know what we do, and we have this data recovery lab. It gives me, I think it should give us all sort of great encouragement to see where we've come from and how rapidly we've gotten there. This is just a rendering of the original data recovery space in our area. Yeah, those are blue pod walls and a couple computers. Myself and another colleague sat in there and we did data recovery work in it. That was our first dedicated data recovery space. Go ahead and play this video, if you will. This is just a brief video. It's old, and I've had it for a long time. And really, the reason I play this for you is to, again, highlight where we came from. That room that we're in there that's shared by a bunch of servers and some video forensics, this is kind of the first big piece of equipment we got. And we're almost in a closet. I mostly show it to you to contrast with the next video I'm going to show you. Also, I want you to look right there, because in a minute, when we talk about this machine in a case, I'm going to talk about something called a vision alignment cube, and that's it. This is a rendering of our modern lab. This is the one that actually exists today. When we moved upstairs into our new space, they were redoing this building that you're in. They gave us the opportunity to kind of draw up what we wanted to do, and this is the one that came to fruition. It's not exactly like that, but it's pretty darn close. This thing in the middle is a Class 100 clean room. Wire bonder that you saw in the last video is over here. Excuse me, the air vac, that's a hot air rework station. There's a wire bonder in that corner, so on and so forth. This is kind of what it looks like. A bunch of cut up slides. We've come a long ways, folks. The next video is just a cut up video that's actually for that passwords machine over there. But anyway, play it because I want you to see what it looks like today. Just snippets of the lab, walking through it. Come a long ways due to some very great support, teamwork, and some brilliant engineers that I have privileged to work with every day. All right, business talk done. It took longer than I wanted it to. But now let's get on to the fun stuff. This is just going to be stuff that's come through that's cool. It highlights a lot of the tools and how, it's a more interesting combination of ways to save it. The first thing you're going to notice is that we lovingly give all of our cases names. We've had a Muddy and a Screech and a Rusty. I don't know if Sophie's still here, but evidently, according to Sophie, we're also 8. This one will become pretty evident in a minute why we call this one Codename Zeus. This was a hard drive that came into our lab. Standard, traditional 2.5-inch hard drive, spinning platters, heads, all that good stuff. It came in from a remote facility. I'm not going to get too specific, and some of the details have been shifted to, preserve the privacy of casework. But this drive came in, and let's just suffice it to say that the data on it had a very large value from a business continuity perspective. The customer had it. It wasn't backed up. I know I'm going to get questions on, do I still do data recovery now with the cloud and stuff? But I can assure you it seems to never go away. The valuable stuff is always magically not backed up or in the cloud or whatever. And Tier 1 support had already looked at this drive. It was dead. That's kind of the word we got, right? So we got it in our lab, and we started triaging it. And we agreed with that assessment. The drive's dead, all right. We plug it up carefully, test it out. It doesn't spin. We put our multimeters on it. We even get out our IR heat gun to see if there's heat in any of the circuitry anywhere. It's dead. So, what's the next thing I'm going to do? I'm going to pop the PCB off, and I'm going to take a look, because obviously if it's a dead, the source of the problem is probably the electronics. So we pop the PCB off, and here's where it's going to immediately become, we're going to skip the words, they're boring, where it's going to become evident why we call this project Zeus. This is a real picture. This little chip right here has got a hole blown in it about the size of a pin, which is unusual, right? Usually integrated circuitry that deep on a board is really well protected. It's got TVSs and stuff all around it because power fluctuates, and they don't tolerate that. So obviously something pretty serious happened here. This chip we call, in my business, a VCU, mostly because no one wants to say voice coil moto servo controller unit more than once a day. I can barely say it up here. But it's the chip that's responsible for controlling the motor in a hard drive. It spins it up. It controls the speeds. It handles syncing to servo timing markers and all that cool stuff. So, the first thought here is I'm going to replace this chip. I'm going to get a donor that's exactly like it. I'm going to try and replace it. So we do that, and I realize that my day's getting worse immediately. I put it on one of my machines, and I start lifting it up. It's not a good start already, because if you look, this is a solderable chip, even by hand if I need to. It's got a lot of pins, but they're fairly far apart. I can probably deal with this. It won't be a lot of fun. But anyway, I heat it up. I start pulling it off, and I realize I'm in quite a bit of trouble immediately when this red orc blood looking substance starts coming out from underneath the chip. That's not normal. I've taken a lot of chips off, and that usually doesn't happen. And I pull it the rest of the way off, and it's kind of hard to see in this picture, but look up here. That's, again, not a modified picture. What that actually is the second layer there on that board and what used to be copper traces that are all fused together. So now I know I'm dealing with a pretty serious impact. You got a lot of techno folks out here. Copper has a melting point of about 2,000 degrees Fahrenheit. Something bad happened here. So what does that tell me? It tells me that this PCB is dead. I'm not resurrecting it, right? So what I'm going to have to do is replace it. Okay, well, the story's getting better all the time. Normally, when I replace a PCB on a hard drive, it would be nice if I could just put it down and be done, right? I don't know if any of you guys are hardware folks. It's not that simple anymore because hard drives have gotten such high capacity and they're such a small footprint that every single one has what we refer to as adaptive data, right? Unique data to that hard drive. And I don't mean user data. I mean stuff like the magnetic profile of the read heads and the exact weight of the head stack as it varies in manufacturing tolerances and the vibration profile of the motor. Normally, it's pretty easy. I look for a little 8-legged ROM chip, it's supposed to be right here on this hard drive, and I move it to the other board. I put the board down and we're good to go. Well, this story keeps getting better all the time, right? It's missing. I didn't take it off this picture, so what does that mean? Hardware folks in the audience? It's embedded here in the MCU. That one's really, really hard to move. It's a 128-pin, 13 millimeter by 13 millimeter quad flat package, and if you look here, this is a millimeter ruler. It's a millimeter, that's pins. That's a really hard chip to move. It's potentially even harder than some of the BGA chips that we move every day because of how close those legs are together and how flimsy they are. We had to end up doing a bunch of tricks to get it to even happen. I'm going to have to speed up or we're only going to have one case study. So this is the machine that we use to do this. I'm going to go ahead and push forward, play the video, and I'm going to kind of talk over it and move on so we can at least hit another case study. This is just a heavily time-lapse modified video. Most of it's looking through the lens of that air vac device. Here I am fluxing it up. The removal's not too hard, right? I use a machine like this. I could even remove this by hand. I want to do it with this machine so that I keep the integrity and the shape of the legs as close to possible as I can. Here it is coming off. Time-lapse. Obviously, it doesn't come off in 3 seconds, but watch the solder go back from liquid to, I didn't leave too much of it here, but it's cool to watch it go back. All right, so here's the cool part, the value add in this machine, these little green dots. I had to freeze frame this because this is really hard to video. You're looking through a bunch of optics, but that cube I told you to look at in the beginning, called the Vision Alignment Cube, is what makes this machine worth its weight in gold. You look through, this thing comes way out there down over your sight, and you look through a bunch of mirrors, and it creates a diffracting optics scenario at a high degree of magnification. A lot of big words, but the end result is your chip is up here in a nozzle, and you're looking down there at your sight, and you get these green lines. You saw them on there. They weren't lined up, but those are the legs, right? And what I can do then is line them up. The table moves, and I line them up really precisely, and I lock the table, and I press the foot session. It uses these force sensors to put that chip down exactly where it goes, and in a case like this, it's invaluable. With ball grid array style chips where there are no legs, it's even more valuable because I can't see into that thing at all, right? Anyway, here we are. I've talked over the whole video. Let's put it back down. This particular case is we had to create some custom logic at the end. After it puts it back down, you're going to see that there's some problems because of how close those legs are together. I end up with some solder bunched up on 2 legs and some shorts and this, that, and the other. So what we ended up doing, you see one right there. What we ended up doing is going back and creating another step where the thing retracts just a little bit, and we blow the air out at just a particular angle. We reflux it first, and I called it hot air solder releveling. Anyway, the end result is we don't reflow it enough to pull it up, but just enough to stop these shorts and make the solder go back where we want it to go. So I'm going to keep talking while this plays so I don't run out of time. We get this done, we plug it up, and now it spins up. We're going in the right direction, right? Unfortunately, it doesn't boot. So we get to diagnosing it further. And perfect. We determined that, well, because of the electrical damage and the loss of the entire protection circuit, this little chip right here called the preamp, which some of you guys may be familiar with, is also blown up. That thing's ribbon mounted, pretty impossible to replace. So what we end up doing is take it inside our Class 100 clean room and changing the entire head stack. This is one of my colleagues, Derek, doing a head replacement. He's going to make it look really, really easy. You guys go home and try it that maybe aren't involved in this and see if it's exactly this easy, see if it works when you're done. I can tell you, I'll build on the panel from earlier. I can tell you learning to do this myself, these guys, some of the guys in here could testify to the number of hard drives I broke, sort of perfecting this technique. It's not so easy. But we pull the heads out of one that's good and got a good healthy preamp and put it over here in our donor, and this video is almost over. Time flies when you're standing up here. And it's done. And we take it back out and we hook it up. It doesn't work again, but we build on our knowledge here, and we know that Western Digitals with lots of heads are pretty intolerant to head swaps, and then we have to do some magic, something we call head shifting. It's basically getting it to boot on one head at a time, and then using the same tricks to turn all the other heads back on, and we image, and we win. We give the customer their data back, and we've employed a lot of techniques and use a lot of equipment that without the great support of the company and the opportunities we have, we wouldn't have been able to recover such a drive. All right, so next case study is more of an R&D project. I wanted to kind of highlight some of the R&D we're able to do in our lab than it is a case study. But several years ago, people started coming in and asking me, hey, I got this micro SD card, and either, you name it, everything from it was in my GoPro and I jumped in the ocean and the flap door was opened, it was in my cell phone that got wet, whatever, and it's ruined and it has really valuable data. It's everything from my vacation pictures to my most valuable company documents to this legal hold to that, right? And honestly, the answer originally was, well, we're not sure. Nobody was recovering micro SD cards. They're kind of a milestone in the solid state storage realm, and that everything we were seeing before that was some combination of a microcontroller and a storage medium, right? Flash ROM chips or NAND chips or whatever else it was. And these particular devices have been engineered down into a single circuit. So, you know, one of the hardest things we deal with in our space is figuring out what to spend our R&D time on. These guys are really, really good to us, and they give us a lot of levity to make that decision, but we want to do the right things. This one was a no-brainer. It's not hard to just say, hey, I want to do R&D in this space, because you're going to see it over and over. It's going to start showing up in smartphones and other devices that, you know, who knows what people are going to ask us to pull data off of. That's kind of our bread and butter. So we said, we don't know, but let's find out. And we started R&D in this process. The original R&D project looks something like these pictures right here. We started taking these little micro SDs and we started scraping the plastic off the back. That was, believe it or not, some of the biggest challenges we face are, you know, far from technical. It was how do you get that off without ruining the chip. I'm looking for taps, right? I know that this technology looks different, but it's not going to be different than the technology, we're used to seeing for this kind of thing, because, you know, what company in the world is going to reinvent the way they do stuff? We're going to reuse something and just make it work into the new package that we want. So sure enough, we started getting these off and finding these taps. We started looking at these taps on our logical analyzers, and like any good, you know, techie, we get fairly excited when we start seeing the patterns we expect. I see data channels, I see control signals, I think I'm going to be able to do something with this. And at the time, hardly anybody was doing this stuff. So then, you know, the biggest hole in this tent was figuring out how do I know I have these signals here, but how do I get this into my programmer? You know, if it's a TSOP48, which is what this is for, you know, the standard chips you see on every USB stick in the world, I can pull it out, I can stick it in that thing, I can pull the data off, and I can do a bunch of stuff and recover it. In this case, I need to get to that step, and this was our first shot in this R&D process. This is a manually soldered job. I can tell you it is not a lot of fun. These little points here are 0.4 millimeter centers. It's about the smallest thing you can successfully solder by hand. And it is not fun. If you screw up anywhere but on the outside edge, you got to wipe it and start over. It takes a long time. It's also very risky to the tiny little piece of wafer board that you're soldering on. And, you know, we work in a forensics world. The last thing I want to have to do is go tell the boss, hey, I melted the evidence, sorry. But it worked. Believe it or not, we recovered the data on that chip. It took a lot of days, and it was an initial first run. We knew it wasn't sustainable. This is why I call the thing Project Medusa. This is try 2, and it's pretty similar, but it's just a progression in the process, right? Let's get a board that's kind of like a test proto board and put some prongs on it, and by then we had this addition to our chip programmer. This is better. It's less connections, it's less risky, it's still not so great, but it's better. While we were working on this, we were drawing up schematics, we were even talking patent for this particular, we're looking at let's invent something that's solderless. Good news, bad news, depending on where your type A personality falls in. While we were doing that, one of our partners, probably our biggest partner in the data recovery world that we buy equipment from, was doing the same thing, and they beat us to this. So the good news is for us, we don't have to finish it. The bad news, of course, we don't get the recognition for the patent. But today, what we use is this thing. It's called the spider board. I'm pretty sure we had one of the first ones in this country. I don't want to say the first because I don't know who all has what, but we got it really early in the process. And it allowed, this is our production process for recovering micro SD cards. You put the card in the middle of it here, and it's got all these metal pins that are heavily insulated except for at the very point, and we line them all up and lock them in place. It looks like that, and then it plugs straight into my chip programmer, and I fire up the software that goes with it, and I can simply say, you know, data signal 1 is on 0.5, and, you know, this control signal is on point, and it's easy. I mean, comparatively, it's very, very easy. I can rig up 4 or 5 of these in an afternoon. There's no risk to my chip because I'm not cranking. I mean, I do have to solder power and ground, but it's easy there. No risk to my chip, and I can do it over and over. I don't feel like I need to pull my hair out when I'm working on these jobs. Case study number 3. This one highlights, this is back in the case study realm. I apologize. I know I'm kind of going quick. I don't run out of time. This is an iPhone 5C that came to us. I've changed the details to a certain degree, but at the time, the iPhone 5C was, you know, that's kind of the first of the, one of the first of the iPhones that applied Apple's new security model that kept us all out. You know, if you've worked on iPhones in particular, you know, we got everything back in the day. It was libpoison or whatever, boot time exploit, and we got everything. They were our favorite things to come in, and then all of a sudden there was a changing of the guard and a line in the sand. I don't know if somebody needed a promotion at Apple or what. I don't know the inside story, but all of a sudden it was the most secure thing produced on Earth. You know, all right. So anyway, this thing came into the lab, and it was a fairly, let's just say it was a legal hold, a pretty high-profile deal, and we really need the data off of this. It's BYOD, but the particular custodian says, yeah, I know, they weren't under investigation. They were happy to cooperate. So they hand it over. But there's a catch, because there's always a catch, right? They'd recently dropped this phone. The screen was damaged, and they'd taken it to a local repair shop who repaired their screen. They had a beautiful new screen, no problem. But they ended up buying them a new phone because, for whatever reason, now it boot looped. It boot up to the Apple logo, hangs there for a minute, starts over. Just does this perpetually. So we know that we need to probably fix this thing. Going through exploits and whatever is not going to be reliable. Our best shot's to fix this thing and get in. So we start doing what any good technician does and, surfing the Googles and the forums that we're familiar with, the reputable sources, trying to figure out if there is any information to at least get us started here. And we found out pretty quickly that, sure enough, this is actually a fairly common problem with, the first time engineers or repair guys do a repair job on this phone. I'm sure a lot of this crowd has probably disassembled your phones before. If you replace a screen or whatever, you got to take a gazillion parts out, and the screws are the size of seed ticks. You drop them in the carpet, you'll never see from them again. In this particular phone up here in the upper right corner, when you get the screen off and all that good stuff, there is a little metal plate about the size of a nickel. It's got a screw hole in each of the four corners, and all the connectors sit underneath it. The screen, the digitizer, the camera, the back camera, the speaker, the Wi-Fi, they're all right there. Anyway, long story short, if you take those screws out and we line them up and we look at them, they all look the same, but if we magnify it a little bit, we'll determine that one of those four screws is longer than the other three. So, maybe a design opportunity, but I won't go there. And what happens is if you put that screw back in any of the other holes, what ends up happening is inside that screw hole, seed tick size screw hole, you end up cutting 3, 4, 5 copper traces, 45 micron wide copper traces. I talked over all this. And the end result's this boot loop. You're looking at it right here. I put a penny in this picture to sort of emphasize it. It's really, really small, right? If you take your soldering iron and put it over that hole, it's just, the answer to this is, you go talk to just about anybody. The answer is you can't fix that. Apple won't fix that for you. Yes, they're making these, but they're not set up to fix this. It's a sterile environment. We throw things away. We don't fix them because, who wants to repair an iPhone worth $200 with, multi-$1,000 equipment? Nobody except the guy that has data on it that's worth more than that, right? And so our business is kind of unique in that space. We did fix this. We used a device called a wire bonder that I don't have time to talk about in depth, but what we ended up using was 45 micron wide traces, so we used 20 micron diameter gold unshielded wire and a wire bonder, and we put those back inside that screw hole and put this phone back together, and believe it or not, we got the data off of it. That's the device we used to fix it. I'm just going to play the video for you. This is what I actually borrowed this video, I have to be honest, from the National Physics Laboratory. It looks just exactly like we do, but this is a hard shot to make. The rest of them I made, but shooting through these optics is pretty difficult, and I was running out of time. These guys expect me to actually do work instead of just make videos. I like making videos. Pretty cool stuff. We're really fortunate to have these kind of tools. I got one more slide. I think I'm going to make it without Tim yanking me off stage. I feel like the time went up or something. The problem with doing things that people sometimes perceive as miracles is that after you've done that once or twice, I think you can fix anything. You guys would be absolutely amazed. I mean, probably not. This crowd probably would not. But it's some of the things they've brought up there. So I have about 45 seconds left, but we'll play a pretty fun game here. These things have all been brought into the lab. This one up here, the picture doesn't really do it justice. That platter's supposed to be clear and shiny, and it's completely scored and cratered. You guys think we recovered that? What do you think? Yes? No? We did not recover that. Believe it or not, that's really not recoverable because of the damage to the substrate layer. You never get the heads to fly. And if they won't fly, they won't calibrate, you're not recovering data. This one, the picture again is a little bit deceptive. I've already straightened this phone. It came in bent about 90 degrees. How about that one? You think we recovered that one? That one we recovered. We were a little lucky, in fairness. You take that phone apart, and yes, the motherboard is broken, but the chips are intact, both the MCU and the NAND chips. So we were able to get one just like it and move those chips, and the encryption is kept, the integrity is good there because the MCU is still matched with its chips, and we get that one back. The next two are, no, I don't even need to start. We definitely did not recover those. I'm going to skip to this one before I come back to that one. No, that's not a rock that I found in my yard. We had a facility that had a very large fire, and they wanted to know if we recovered the DVRs. We turned one of the DVRs over, and that fell out. I did not get any data off that rock. I'm pretty good, but... This one is clear right here on this line where the SA is. The rest of the platter's okay. Anybody think we recovered that one? Yeah. That's a trick question because 98% of the time that is not recoverable. This was a multi-platter hard drive, and the moons aligned, and we put a platter that didn't belong with it on the top and put it out the bottom. We recovered part of the data off this hard drive off the other platter. I'm over my time, so I'm going to shut up now, and if Tim lets me answer questions, I will. Thanks, guys. I very, very much enjoy what I do, and I appreciate you guys listening to me, and I've enjoyed this entire con. I hope you guys have enjoyed it as well.
Yeah, who's got questions for Mr. Wayne Murphy? I'm sure we got a lot, and one more obligatory, no swearing. There you go. So hashtag SparkCon, hashtag no swearing.
So this question kind of relates to when the FBI was trying to get into an iPhone this time back in time of year back in 2016. But what are your thoughts about companies like Cellebrite and other exploit vendors who make claim to being able to break into devices for the means of forensic? And do you feel like this is an attack against privacy and security, or within reason and justifiability in the context of law?
You loaded this up on every point. Okay, so that's something we are very familiar with, right? It's right in our wheelhouse, and these are our business partners being a forensic unit that you're talking about. So let me see if I can remember them all and address them briefly in order. As far as Cellebrite goes, absolutely legitimate company doing some great work. They got a couple of the Israelis that work in their home office are brilliant guys. I've had the pleasure of working with them on some stuff. And what they're doing, what they're offering is bona fide. They are, for the most part, in kind of living in Tim's world and using exploits that are out there and sometimes custom stuff. So it's less applicable to a company like ours that's forcing patches every, really, really fast because the things update and you can't stop it, and by then it's too late. But as far as the private sector goes, it's just a matter of kind of wait until something comes around. We've directly sent stuff to them in certain cases where we could put it in the Faraday box and stop it from getting patched, and then the exploit comes out and they are able to take care of it. It's expensive because obviously they have to pay all that R&D back. Yes, they're legitimate. No, they can't get everything back like any of the rest of us. And I don't know, it's sort of tough for me to answer. That's a pretty subjective question. Is it an invasion of privacy or not? I think I fall in probably a similar crowd as most of you. I think we should, as practitioners, try to secure our stuff, and I think we should pen test our stuff. And it's the world we live in. I'll leave it to you personally whether you agree with the politics behind it or not. I think it's our right to do it, at least in this great country that we live in.
All right. Yes.
Yeah. Usually, if you put a small little scratch on a CD, we couldn't able to read that. So, even if it is a very minute scratch, so how do you extract the data from the CD in that case?
Are you speaking a compact disc or a hard drive platter?
It's a compact disc, a regular CD.
And compact discs are pretty easy because there are actually a lot of layers on the outside that protect it, and usually you can grind them back down. In our lab, we have a run-of-the-mill disc repairer like you'd see out in a video game store. For years when that was the thing, right? Before everybody downloaded everything, you'd take your CDs, your whatever, to the video game store, and they would polish them up, and magically they'd work again, right? I guarantee you we have some people that have partaken in that in this building. I know I have, and we have one of those. It works pretty good. So on CDs, that's one thing. If we get into hard drive platters, it's a totally different thing. Resurfacing those, we've looked into some stuff like that. We've tried to partner with some nanotech labs. That's a tough road to hoe there.
Okay.
Did that answer your question or no?
Yes, you did. Thank you.
Absolutely. Thank you.
Yo. So, whenever major changes happen in computing, that obviously has some pretty, potentially significant implications for forensic work. Most recent example being Apple's move to APFS.
Sure.
I'm curious if you can speak on this. Due to the sophistication, the level of sophistication in Walmart's forensic lab, do you guys play any sort of critical role in creating the new tools that can image, those sorts of those drives that can still take forensic copies of data of brand new technologies, or are you guys even at the whim of organizations like FTK, NCASE, et cetera, et cetera?
I can sort of answer that, I think, without stepping on any toes or saying anything I'm not supposed to. In the forensics world, that's such a big world, and I know exactly where you're coming from, but it's scaled up so fast, and that's kind of one of the reasons I was showing kind of where we came from and where we were going, that now there's a lot of money in that world, and there's a lot of labs practicing that, and it's interesting that you mentioned APFS, because in our environment, apples get patched rapidly, and we're seeing High Sierra within days, coming into our lab, within days of it hitting the market, and that was a big problem. The vendors weren't there yet. They were working furiously on it, especially the vendors that are, Mac is our bread and butter. And so there's a bunch of folks in the audience, I imagine they're laughing because a lot of my team members are here and we've worked on this all together. It's been a pain point. But what we do is we find a solution that works right now, and we get on the phone. We know the vendors because we're a big company, we have that privilege, and we ask when it's coming and we try to push them along, and we find a solution so we can serve our companies in the meantime, and that's one we've just went through. Right now it's too many steps. It's not greatly sustainable over the next year or two, but I can get the job done, you know what I mean? And we're there on APFS. At least one of our vendors has in support for it now, but during the few weeks where they didn't. So yeah, we're in the same boat as the rest of you guys. We're fortunate enough to have some good contacts, but it's the same thing. On the data recovery side of the house, some of that stuff just flat has to be invented because nobody else is gonna, and that's, okay, this particular brand of SSD that we bought a really lot of is failing, and none of the recovery laboratories are probably gonna come up with a solution because there's 9 billion things they're working on, and not enough people are buying that SSD, except in our case. So that's the kind of things we end up having to invent and put a ton of resources in, where we just want to leverage our partnership with the great forensic vendors out there on the other side.
Get another question over here.
With the thing with the SD card, where you were trying to come up with a proprietary technology to make that technique easier, do you guys more often find out that what you were working on was already perfected by another company, or do you more often make it yourself first?
That's an interesting question because we've gone down that path a few times. You take your 20-sided dice and roll it and see. That's what I would tell you, because sometimes it may be surprise you. It's to market in 2 months. And other times I think exactly like you think. I'm not going to touch this. Somebody's going to have this out. And I never do see from it. So I think you just have to go, how valuable is this to myself and my organization? Does it really warrant the R&D time? And let's work down the path. And if it's something we get done, great. And if somebody else beats us to market, let's return our time elsewhere. You know what I mean? That's how we generally approach it, if it has the value to warrant such a thing.
Any other last questions? So why couldn't you get the data off the rock?
I put it in a lab hold. I figure one of these days we'll get there, but
It kind of looked like a dinosaur egg to me. I don't know if anyone else thought that. It was like Jurassic Park.
It's sitting on top of one of the devices in the lab. I like to show it off. It's our pet.
Yeah.
Thanks, guys. I enjoyed it. Thanks for having me, Tim.